Welcome to the how-to video for redox reactions. Redox reactions are also known as oxidation-reduction reactions. And in these reactions, we're just transferring electrons from one reactant to another. And so in these, you always have oxidation, which is the loss of an electron, and reduction is the gain of an electron. The easiest way to remember this is really just the term oil rig, where oxidation is loss and reduction is gain of an electron. There's many examples of this oxidation-reduction reactions in nature. So when we think about an oxidation-reduction reaction, it's really just a single displacement reaction. And in these reactions, you're basically talking about where you have something like A plus Bx. And in this case, we're just doing a single displacement reaction where A can push B out. This produces AX plus B. We can also have different oxidation of metals by acids or salts. And so we could have something like zinc, which is in its elemental form, which means it's a solid. And it reacts with an acid such as hydrobromic acid. What happens is zinc is going to kick out hydrogen, forming a salt, which is zinc bromide. The zinc combines with the bromide, and we produce hydrogen gas. Anytime we kick out hydrogen, we form hydrogen gas, back in its elemental form. We could also have a metal, such as manganese as a solid in its elemental form, reacting with some kind of salt, in this case lead nitrate. And what happens is manganese is going to kick out the lead to produce lead in its elemental form and some kind of salt. So we just said that metals can undergo a displacement reaction with acids, and when they do, they produce a salt plus hydrogen gas. We could write out what that reaction would look like, and we could calculate the oxidation numbers. We could also look at what is the net ionic equation. Here we have magnesium metal reacting with two hydrogen ions to form magnesium ion plus hydrogen gas. And we could identify what's being oxidized and what's being reduced. Magnesium went from a neutral charge, 0, to a 2+ charge. And so in that case, we could really think of magnesium, which went from 0 to 2+, and in that case, it means that it must have lost 2 electrons. Well, the oxidation is the loss of electrons, and so in this case, magnesium was oxidized. Where the hydrogen ion went from +1 to neutral, meaning went to 0. And in that case, it really means that we went from +1 to 0, and the way that we did that was we gained electrons, which means that this was reduced. So it's important to understand that when one substance is oxidized, another must be reduced. The way that we can tell if an oxidation-reduction reaction will occur is we use the activity series. And really, this activity series is just a list of metals arranged in order of decreasing ease of oxidation, right? So here we can see as we go up the table, we're getting an ease of oxidation increases. The way I like to think about it is things at the top are the most reactive, whereas the things at the bottom are the ones that are unresponsive. They're going to be the least reactive. The easiest way to think about it is the higher up you are, the more you can replace in solution. And so if we have something like lithium, which is all the way up here at the top, and it's a metal, it can basically replace anything below it, which is part of a solution. So lithium plus something like manganese chloride, the lithium can replace manganese in the solution, because manganese is below lithium in this table. And we say, okay, well, copper is here on the table, silver is below it, which means that copper can replace silver in the solution, not the other way around. So when we think about a reaction here where we have silver nitrate reacting with copper solid, so we have our copper metal that we're just sticking into the solution of silver nitrate. What happens here is the copper metal can replace silver in solution. And when it does, silver is going to be kicked out as a solid, and you're going to form copper nitrate solution. Well, this copper nitrate solution is kind of blue, and you can see the silver that's depositing on the actual copper wire. So copper is oxidized while silver is being reduced. part of the reason we know this can happen is if we go. This concludes how to for the redox reactions.